Hey everybody, this is Dr. Wood, and today I'm going to be covering some of the stuff from Chapter 6 with you, and it's going to be a little bit of a math review. Don't get too scared by the thought of doing math again. You're going to find that in medicine, unless you're extremely specialized in doing something outside of the typical realm of medical practice, you don't find that the math you have to do is all that intensive. And so I kind of want to get you up to speed here in terms of what you might be needing to look at and what you might actually be doing if you enter the healthcare field one day. I think that this is a very good illustration of the math skills that you really need in medicine. Here's a Twitter post from a physician. They're an attending physician. They said, "I don't know why I ever took calculus. I wish I'd just taken math classes where you have to multiply two numbers while someone is dying and everyone else in the room is screaming at you." And I can tell you, I've been in that situation before with, when you're having a cardiac arrest going on, or if you have a patient who's seizing in front of you, and you have to figure out the dose to administer for a patient based off of, the concentration of the medication you have. And I'm sitting there trying to figure out what to draw up, and I have people screaming at me, "We need the meds now, we need the meds now." And it can be very intense. And again, not difficult math, but doing it under pressure is what's tough. So by getting you kind of up to speed on the basics here, it'll help you be prepared for when you're actually having to do those in live sort of conditions. So anywho, starting off with the basics here, we have fractions. Of course, we have three varieties we're going to be talking about here. There's proper fractions, where basically that numerator is always going to be a lower number than the denominator here. So it's always going to be never going to be actual whole number, or more than a whole number. Is going to be just a fraction, straight and simple. Improper fractions are typically where we're going to have the numerator being equal to or greater than the denominator here. So in this case here, 5 over 5 is all we know to be just 1, but this is also considered to be an improper fraction. Similarly, 3 over 2 or 11 over 6, because it is bigger than the denominator, it's considered improper. And then certainly we can have a lot of equivalent fractions where 2 or more will have the same proportion of the whole, right? Or same portion of the whole here. So you can see that 5 out of 10 is the same as 1 out of 2 is the same out of 3 out of 6. Again, not scary so far, right? Should be pretty straightforward. So some of the things you might have to do is when you're trying to simplify the fractions down to a lowest term, this is pretty straightforward here. To do that, you can just divide the numerator and the denominator by the largest number that will divide both, right? So this is where you're trying to find sort of a lowest common denominator just for one fraction here. And again, if you're looking at 5 out of 10, or 5 over 10, 5 will divide into both 5 and 10. So basically what you can do is take 5 over 10, which is what our original fraction is, divide that by 5 over 5, because that's essentially how we're going to be getting down to a smaller value there. And again, 5 over 5 is 1, so anything divided by 1, it's still itself, right? And so it ends up turning into 1 over 2, or 1/2, right? So most of you can probably intuitively do this in your head. But again, just to kind of spell it out and to make it a little more explicit in case anyone was ever just curious. Now, when you're dealing with mixed numbers, this is where you can find improper fractions can be changed over to a mixed number, and basically you'll have the whole number plus the fraction itself, right? So in this case here, if you had 19 over 11, you can just divide out both by 11 there, and so you end up having 1 and then 8 over 11 as your remainder there, right? So again, 19 minus 11 essentially is you're going to have that 8 left over. And so you have 1 and then 8 over 11, right? So it's a mixed number there. In the case of 12 over 8, that can then be just divided by 8. And so what you end up having left over is 1 and then 4 out of 8. And then you can further simplify that even more by saying, okay, well, that's just 1.5 essentially. 1 and 4 over 8 is just going to be 1.5. If we're going to be adding fractions and mixed numbers, if they have the same denominator, it tends to be pretty simple here. So here we can just add the numerators and carry forth the denominator. So as an example, if we had two fractions, one was 5 over 6 and 2 over 6, basically that would just equal the numerators added up together, and so 5 plus 2 would equal 7, 6, essentially, right? Now once we do that, then we can change it to a mixed number, right? So basically that would end up turning into 1, so that's the whole number 1, and then 1/6 is left over, okay? So if you ever need to take a mixed number and then add those to another fraction with the same denominator, basically you just need to turn that that mixed number into a fraction in the first place. And we'll talk about that in just a moment here. If the fractions or mixed numbers have a different denominator, then basically we want to try to make both denominators the same. And so this is, again, I kind of mentioned this before, but where we try to find the lowest common denominator between the two here, the LCD, right? It's not your screen you're probably looking at, but the lowest common denominator here. And so basically it's going to be the lowest number that can basically evenly divide both of the denominators present there. And then you just replace that denominator with that particular number. Okay, and so we're going to find the equal fraction for each number, dividing the original denominator into the lowest common denominator, and then multiply the numerator by that same number obtained there. And then we'll just add the numerators and simplify as appropriate. What does that mean? Let's look at some examples here. Let's look at 5/6 and 7/10. Both of these denominators can actually be divided into 30 reasonably well here, right? So looking at this, if you were to say 5/6, well, 30 divided by 6 equals 5. So basically, I'm just going to have to multiply the numerator by 5, and that'll end up giving me my new numerator here. Then this is the step here. So basically, 5/6 is equivalent to 25/30ths, right? I can do the same thing with the 7/10, where basically 30 divided by 10 is 3. So I'll just multiply that 7 by 3, and then I end up getting 21. So 7/10 is going to be equivalent to 21/30ths, right? So now that I have both of my fractions in the denominator being both 30, I can just add these up now, and I'm getting 46/30ths. Now, of course, we can simplify even further, and so we can turn this into a mixed number where you have 1 and 16/30ths left over. Or if you wanted to, simplify that further, you could say 1 and 8/15ths. Okay. If we're going to be subtracting fractions from one another, again, you can do the same thing. You just have to find the lowest common denominator and then subtract the numerators from one another. Let's look at the example of having 7/9 and then 1/6. Obviously, these denominators are incompatible as it currently stands, but let's find out what the lowest common denominator is going to be between these two. So looking at this, we can find that 7/9, basically 18 is going to be the lowest common denominator between 9 and 6. So here what we can find when converting this and using the same steps as the previous slide, 7/9 just turns into 14/18ths, and then 1/6 would turn into 3/18ths. Now we can subtract these from one another, and I'm getting 11/18ths left over. At this point, it can't be further simplified because nothing can be evenly divided between 11 and 18 at that point, so we're just going to leave it at that. Again, if you're starting out with a mixed number, just turn it to an improper fraction first, and then you should be good to go in terms of finding that lowest common denominator. So what do you do if you need to multiply fractions? Well, this is pretty straightforward. You're just going to multiply straight through on both the numerators and the denominators, such that you will have, say, 2/5 times 3/4. Basically, you just multiply the numerators out, so 2 times 3 is going to be equal to 6, and then 5 times 4 is equal to 20. And so now this turns into 6/20ths, or as we can divide it out by 2, we'll find that 3/10 is going to be the simplified form of that. If we're going to be multiplying mixed numbers, basically what you want to do is convert those over to an improper fraction, kind of like what we talked about before with the adding and subtracting there. But if we can, try to cancel out any numerators by the denominators if possible. And then at that point, we can multiply it straight through. So let's say, for instance, we have 5 1/3 times 3/4. Basically, you could just turn this into an improper fraction here. So basically, 5 as a whole number would be equal to 15/3. Right? And then add that to the 1, so you'd have 16/3 left over, and you multiply that times 3/4. So 16 times 3 turns into 48, and then 3 times 4 is equal to 12. Divide that out, and guess what you got left over? Nice whole number of 4. Dividing fractions, this one is almost as simple as multiplying, except we're going to do one little step here, and what we're going to do is basically get the reciprocal for the second fraction, or when I say reciprocal, it just means you're going to invert it. And so in this example here, 5/6 divided by 11/12 would just be equal to 5/6 times, notice here we've switched from dividing by to multiplying by, 12/11ths. Okay, the reciprocal of 11/12 is 12/11ths here. Multiply that out. 5 times 12 is 60, and then 6 times 11 is 66. So now you have 60, 66, and then to simplify that out would be 10 out of 11. Okay. Again, as always, if you have a mixed number, turn it into an improper fraction first, and then you should be good to go. So decimals basically are going to be more of a fractional part of a number, and so to my mind, these are a little bit more concrete to wrap my head around than actually looking at fractions. They've always seemed a little more abstract to my mind. But basically, when you have a decimal to the right of a whole number, that's going to delineate that there is some fractional bit of a number sort of left over. If there's no digit to the left, so if you have a value that's less than 1, you always want to add that 0 to the left there. Remember, we talked about having leading zeros in order to avoid confusion. In that way, something like 0.1 would be written as 0.1 to avoid being mixed up and just being read as 1 potentially. But you can turn a decimal back into a fraction or a mixed number there. Basically, anything to the left of the decimal remains a whole number. Like in this instance here, 12.467, 12 would be the whole number. And then anything to the right of the decimal, since that's the fractional bit of a whole number, becomes the numerator for the fraction. And then the denominator is basically going to become the power of 10 with a 0 for each place after the decimal. And so basically what that means is you start off with the value of 10, right? So 10, 100, 1,000, right? So that's going to be basically what your denominator is going to be at that point, right? The tenth, hundredths, thousandths of a decimal. And so that 467 is your numerator divided by 1,000, essentially. So you're going to find that rounding is really, really important when it comes into dealing with medications, right? You can find that you can, estimate out to the millionth place, but if that's something you can't theoretically measure, or if it doesn't really clinically make a difference to your patient, there's no point in really doing that. So it's important to understand on the clinical context where the right amount of rounding is going to be to, right? And so basically you're going to be rounding to multiples of 10 there, and what we're going to do basically when you do round is it shortens the decimal by dropping off some of the digits behind it. And so for our purposes here, if the digit's 5, that's going to be determining the rounding, okay? And I'll show you what that means in a second here. So if a value is 5 or above, you just round up, and if it's below 5, you round down. Okay, it's pretty standard in medicine. So as an example here, if we have the value 5.456, there's a few different ways that you could round this, right? So if we wanted to round it, say, to the hundredths place, by looking at the value of 6, it's above 5, and so I would end up just rounding that up. So 5.456 rounded to the hundredths place would be 5.46. It's pretty precise, not as precise as having the thousandths place accounted for, but still pretty good for the most part. What if I wanted to round that further, say to the tenths place? Well, looking at the 4, I have that 5 there. Basically, since that's 5 and above, I'm going to go ahead and round that up as well. So 5.456 rounded to the tenths place would end up being 5.5. But look what happens if you end up rounding to the whole number place, right? So because 4 is less than 5, that ends up rounding down. So at that point, if you wanted to round just to the whole number, 5 would be the value you would get there. And so again, depending on the context, rounding to the tenths place may be appropriate, or rounding to the hundredths place might be more appropriate. It just depends on what you can measure, what kind of clinical difference it'll make for the patient. It's going to be very dependent on your position and what the context is. So if you wanted to convert a proper fraction to a decimal, this is something you might be doing a little bit more commonly. What you're going to find is you just divide the numerator by the denominator. So it's a very simple example. 9 divided by 10 is equal to basically 9 divided by 10. That's what that slash basically means. Turns into 0.9, right? Notice here, because this is a value less than 1, I always want to have my leading 0 here. So it's 0.9. Not just 0.9, because someone could accidentally misread that as 9, and that would be a tenfold overdose in some cases, right? Another example of this would be if we were converting, say, an improper fraction. Again, you're just dividing the numerator by the denominator here, and so in this case, you're going to find that 14 divided by 8 would be equal to 1.75, okay? So with percentages, it basically just means a hundredths or part of 100, right? So again, if you have 100%, that equals 1 essentially, right? And again, you may see it demarcated as either a fraction, a whole number, or a mixed number depending on the situation here. And so as an example, you can see here 1 divided by 4%, that's 1/4% or 0.25%. Or you could write it as 1 1/4, so 1.25% would be another way that you could write that. Again, it depends on the nomenclature that what you're looking at, whether it's a journal or a medicine bottle, wherever the case may be. They'll demarcate it in different ways there, as you'll see. But basically, when you're dividing it out, it's always going to turn into the same sort of decimal number there. And so you typically want to reduce it down to that decimal number for further calculations. That's going to make it much easier when we're trying to multiply or divide things together. Now, when you have percents that are being expressed as a fraction, they're not super useful for our purposes in terms of calculations. And so what we're going to be able to do is to change that over into the actual decimal number here, right? Basically what you end up doing is, say for instance, we have a 1/4%, so 1/4%. Turn that into the actual decimal number here, right? So again, that's 0.25 of a percent, right? So 1/4 of 1%, or 1/4 of 1/100th essentially, right? And so to convert that over into the actual decimal number, basically what we can just do is divide that by 100. So you drop this percentage sign, divide by 100, and essentially what that does is it moves the decimal place 2 points or 2 places to the left here, right? So if you imagine moving a 1 and then 2 places over, 1/4% or 0.25 of a percent turns into 0.0025. Okay, so again, a very small number here, but we deal with numbers this small all the time in medicine, as it turns out. Another example of this would be, what if you had 2.5%, right? So 2 and 1 out of 2%, basically 2.5%. You could drop the percentage sign, divide by 100. You're going to move the decimal place over to the left 2 spots. And that turns into 0.025. So saying 2.5% is equal to saying 0.025, right, as a decimal number there. So if I wanted to do the opposite, I wanted to change the decimal back into a percentage. Again, this is just the opposite of what we did on the last slide. And so here we can either take a value and multiply it by 100, or what we can actually do is just move the decimal place 2 places to the right. And so in this case here, if you had the value 2.64, it would basically become 264%, right? Because again, it's over 100% because it's over 1, and then it's actually over 200% because it's over the value of 2. So moving this over 2 places to the right, you would see here that 2.64 becomes 264%. This is basically showing the same thing. Note here we don't keep the 0 after the decimal, you just drop the decimal altogether because now you have a whole number here, right? And again, you're putting the percentage sign here anyway. What would happen if we had, say, the value 0.022? The same thing can happen. You just move the decimal place 2 points over to the right. So again, 1 and then 2, and that turns into 2.2%. Fairly straightforward, okay? So sometimes you're asked to multiply percentages together, or when you say, like, I want to find the blank percent of a number, that of just means that you're multiplying that number by a percentage there. And so that's pretty straightforward to do. Basically, we can just change that percent and turn it into a decimal number and then multiply by whatever value we're looking at, right? So basically what you have to do is convert, say for instance, with our example here, we want to find 3% of the number 42. Basically what we're going to convert this over into is turn this into a decimal number here, right? So what I can do in this case is if I had 3%, I'm just going to move that decimal place over 1 spot and then 2 spots, and now my decimal place is now here. So basically what this turns into is 0.03, right? I'm going to take that 0.03, which is equivalent to 3% essentially, and I'm going to multiply that by 42. And again, I really apologize for my poor handwriting here, but you guys will have to deal with it. So 0.03 times 42, and what does that equal out to? And in fact, I have to get my calculator out because I did not put it on here. But 0.03 times 42, and what do you get? It should equal out to 1.26. So you would say that 3% of the number 42 is 1.26, right? So pretty straightforward. So if you have a mixed number, again, you just change that mixed number over into the decimal form. So for instance, with the value 3.5%, right, of 90, what is that going to turn into? Well, basically 3.5%. I'm going to multiply that out, and essentially what that turns into is 0.035, and kind of go back over the slides and kind of work through the math with me, and you should make sense there. So 3.5% turns into 0.035. I'm going to multiply that by 90, and what do you get? 0.035 times 90, and you should get 3.15. Okay, and after a while, you're going to be able to turn these percentages over into the decimal numbers fairly quickly. It just takes some practice and looking at the numbers several times, and then eventually it'll come pretty natural to you. Especially if you're working in pharmacy and you're dealing with these numbers all day in and day out, it'll come second nature to you after a while. What if I wanted to divide by a percentage? So if I wanted to say 15 is what percent of 45, right? you got to figure out what the question of what is at that point, right? So 15 is what percent of 45, that what is the percentage you're actually looking for. And basically what you can do is set up the problem as a fraction, and then you just simplify the fraction as possible, and then convert it back over from a decimal to a percentage, right? So I wanted to say, what is 15 is what percentage of 45? Well, basically write that out as 15 divided by 45. I end up getting the simplified down to 15 divided by 45 is equal to 1 over 3. By dividing out 1 divided by 3, you see that 0.33 is the answer there. And so I can then say multiply that by 100, or just move the decimal place over 2 spots to the right, and that turns into 33%. Okay, so I could say 15 is 33% of 45, roughly speaking. So what if I wanted to use fractions to figure out a percentage, right? Which you can use the basic algebra to solve for a question like this. So for instance, if you're asking the question, what is 20% of 200? Well, a pretty straightforward calculation you might be able to do in your head. If you wanted to set it up as an algebra problem, basically you could say x, which is what we want to find out, over 200 would be equal to 20%, so 20 out of 100, and then solve for x. So what can I do here? Basically, I can multiply both sides by 200, right? Times this by 200. And then here you'd find that 200s cancel out, and x would be equal to 20 times 200 over 100. And so when you do that, you say 20 times 200 is equal to 4,000. Over 100. And basically just cancel out some of these zeros here to where you get basically 40 over 1, or 40 would be 20% of 200. Okay. Again, the other way you could do this is just to turn this 20% into a decimal and then multiply it out. So I could just basically say, okay, well, let me just move this decimal place over 2 spots to the left. So I can get 0.2 is equivalent to 20%, and do 0.2 times 200, and you get the same value as well, right? So kind of 2 different ways to do the same thing, essentially. So let's look at this another way. Instead of trying to figure out, say, what that original percentage is, or that value that the percent is, let's figure out what that base number might be here. And so let's say, for instance, we're asking the question, 15 is 33% of what number? You can set this up where x is now going to be the denominator on this side here rather than on the numerator on the slide previous to this. And so you can say 15 over x, which is what we're trying to figure out, is equal to 33 over 100, right? So basically, by rearranging this a bit, which you have to take some liberties here, hopefully you remember some of that basic algebra we've taken before, solving for x, what you can basically see is that 33x is equal to 1500, and then dividing that out, you end up finding that x is equal to 45.45. Otherwise, basically x is rounded down to 45 in that case there, right? And actually what I like to do when I'm doing this, because I have to figure out these numbers quite frequently when I'm doing some dosage calculations here, basically, again, I just take this percentage and I turn it into a decimal, and I say move this over 2 spots to the left, right? So now I have 0.33, and I just take 15 divided by 0.33, and it actually gives you the same number here, right? So I'm just double check myself, 15 divided by 0.33, and you can double check as well, and you find that you actually get the same value there, right? So again, different ways to solve the same kind of problems. Here's a case again, if we're asking the question, what's 33% of 45? Again, the x value is just now the numerator as opposed to the denominator on the slide last. Again, multiplying this through and solving for x, you end up finding that x is equal to 15, thereabout. Again, when you're rounding this decimal here, because 8 is greater than 5, or 5 and up, it gets rounded up. So basically you just say, okay, well, this gets rounded up to 15 as a whole number. Now let's talk about ratios and proportions. Basically, a ratio is just showing the relationship between 2 different numbers there, whereas a proportion is showing the relationship between 2 different ratios. And so basically, by using this proportional method, you're able to find out the relationship between 2 different ratios together, right? This also means we can find out for many unknowns, and it's kind of similar to some of the previous basic algebra equations we were looking at previously in the past couple slides here. But we do this pretty often for dosage calculations. And so just to keep in mind in terms of nomenclature, if we have 2 colons together, it's going to be showing the relationship between 2 different ratios, right? So it's going to be a proportion, and then 1 colon is going to show the relationship between 2 numbers. So that's a specific ratio there. So when looking at ratios and proportions, basically if you're able to solve for x in any of these cases here, what you have to do is arrange it like this, and it almost looks like one of those SAT questions. You're looking for those analogies there, but basically you're looking at these two ratios together, so 1 to 4 and 2 to 8, and you're looking at the proportion between them. In order to solve for one of these variables here, what you have to figure out is that the product of the means, which are going to be these two internal numbers, must equal the product of the extremes, which are going to be the external numbers in these cases here. And so by solving for x in a given proportion, it's fairly straightforward, but in this case here, let's look at it. So we're going to see here that 1 to x is going to be related to 2 to 8. And so we need to figure out what this x actually is going to be here. So the product of x and 2 have to be equal to the product of x, or 1 and 8 in this case here. So by looking at the extremes, 1 times 8 equals 8. It's pretty straightforward. And then 2 times x is going to be the means, the product of the means that we're looking at there. Okay, so 2x has to be equal to 8. And so by dividing 2 by both sides, you're going to find that x is equal to 4. And you can see here how it makes sense based on what we were looking at previously. And again, you could solve for any one of those numbers there the same way. It just depends on which variable you're actually looking for in those cases. So using ratios and proportions to figure out the percentage, we can say that 15 is what percent of 45. And so in this case here, 15 and 45 are the numbers actually being compared. So if we're looking at this, we could see, the what is going to be the actual percentage that we're trying to determine. And so in this case, the formula would be that 15 to 45, so that's one ratio, is going to be a similar proportion to x percentage over 100. And so by figuring this out, by figuring out what x is, so x times 45 should be equal to 15 times 100. And so 45x equals 1500, you can see here. And so when you solve for that, so dividing both sides by 45, you find that x is equal to 33.3%. And this is corroborated by the previous ways that we've calculated this before. Again, just kind of showing you multiple ways to figure out the same thing. You'll find which way kind of works best for you, and just kind of stick with that. As long as you get the right numbers, no one really cares how you do it. So let's say we wanted to figure out 21 is 60% of what number? How can we figure that out? Well, basically, we could say 21 to x, because again, that whole number is what we're looking for here, in proportion to 60 over 100. Basically what we can do and say is that 60x has to be equal to 2100, right? Divide both sides out, you end up getting 35. So 21 is 60% of 35. What number is 60% of 35? You can do the same way, just solve for a different variable here. So x to 35 in proportion to 60 to 100. Again, the proportions are all the same here. By solving for this, 35 times 60, it's going to be 2100, has to be equal to 100x. Divide both sides out, and you get 21 as your answer here, right? So fairly straightforward. And so that's it. That's kind of the majority of the math you're going to be doing in terms of at least pharmacy calculations. I know it may seem kind of underwhelming, but I always say KISS. I say keep it simple, students. Don't try to complicate things any further. And so even though you have to take calculus to get a lot of the degrees you might be seeking one day, to be fair, you might not use a whole lot of it, right? So basic algebra, get those basics down, be able to be comfortable working with percentages and fractions and all that, and you should be good for at least for a career in pharmacy. Okay. If you have any questions, let me know, and I'll talk to you soon. Thanks a lot. Bye.